Okay, so let's get started with the quick rundown of what we're going to look at today. So this is our second day of workshop. The agenda is set up, so we are going to look into details of quantity takeoff from a Revit model as well as from an IFC model. All right, so that's going to be our first topic for today. And then we will go ahead with generating rebar quantities. So obviously there were a lot of questions yesterday in regards to reinforcement. Now we will look into details of reinforcement, how we actually can determine quantity of reinforcement from a beam model. So that's going to be our second topic for today. After that, we are going to go ahead with rebar standard measurement rules, which are inside of the software. So how we actually deal with that, how you make changes and stuff like that. Also, we'll look into details of rebar 3D visualization and how it's going to help us in determining errors or making changes or making decisions. In other words, if you are a designer, that's a good news for you. But if you are not a designer, then you are doing the quantity takeoff, and at that time, it's also quite essential to have access to all of those 3D rebar information. After that, we're going to go ahead with announcements and stuff. So training programs, that's not included, by the way, in today's workshop, but we're gonna keep that aside for now. But you will be able to get to see that once we are done with the workshop. So that's there. And finally, of course, we'll conclude with our Q&A part. And I would expect everyone to join in and start having conversation from your side. If you have any suggestion, that's also most welcome. If you have questions related to the topic, outside of the topic, free discussions are always welcome. Okay, let's get started with our first topic for today, Revit or IFC import using QBCost. So inside of QBCost software, we're going to use the tool for importing Revit as well as IFC. All right, so I will start with our Takeoff software, which is TAS, but you might be able to see that there is a little difference with the version of TAS. So what we looked at yesterday was TAS C3 TIO, but this is again, sorry, the last one was TAS C3, but this is TIO. So TIO is basically the one where we get to the details of Revit or IFC. Now, for me, I don't know how many softwares are there in the market who can actually edit a Revit model, but all certainly I can see that this software can actually give you access to edit Revit model, and this is not a Revit software in the first place. So that's the first point to talk about. Let's just get into details of the Revit import. So first of all, we're going to create a project for today. I'm going to call it as Revit or IFC import. Okay, and then I'm going to select a measurement rule. So of course, this question was there yesterday, but what I'm going to do is that I'm going to try to highlight the points in regards to the difference between the TAS C-TIO and Revit. Okay, how Revit quantities are different from this one. So as I mentioned, the biggest point is the measurement rules. So you have measurement rules, which is basically covering all of those stuff related to the rules, let's say relation between elements, how the deductions are taking place, how calculation rules are getting applied to each one of them. So this is the biggest part. I mean, you can get just a quantity, but that is, again, you have to fit into the Excel and start working on your deductions and stuff, but that's not happening here anymore because you have the rules of measurement inside of it. But because there is rules of measurement in the software, the Revit model needs to follow some rules of modeling, and if you follow those rules, then it's going to be a perfect model for TAS to work out your way. So that's the first point. Let's just go ahead with the first principle of measurement. So we have got principal measurement UAE for me, right? And then I'm going to just start the project. Okay, so looks like we have many participants who are still joining in. Okay, that is really good. Okay, so initializing project. This is where of course, we looked at this interface, no introduction needed, I believe. What's different between the yesterday's software and today's software is that we have Revit import just right here, which is coming only in Tayo. That's a little bit of, advancement in the software. So you have this additional feature inside of this version. So you can go ahead with Revit import, you can go ahead with IFC file. Okay. So first thing first, we'll try out with Revit first, and then we will do the similar stuff with IFC model, and we'll see the difference. Okay. So if I go ahead and just click Revit file, that's going to bring up the Revit file. But before that, I would actually like to look at my flow setting. Okay. So we know from our yesterday's topic that this is where you set up basically the flow levels and stuff. But normally I just stick to the default setup, which is just foundation, ground floor, and first floor with different grade settings. So not touching any of this stuff at the moment. We're going to go ahead and start importing the model. Okay, so BIM model, import Revit file, and this is why I'm going to select the Revit model. Okay, let's just get to the file, and that's inside of here. So we've got a Revit model here. Okay, just gonna say, okay, import that. Okay, and then again, I'm gonna press open. Now, what's important to notice, as I mentioned before, that you have to follow certain rules in order to fit that model in the software while modeling the Revit model. Now, these rules are always, there's a guidebook, so you can follow that guidebook. It's just like, you don't have to use the same name for another material. Don't use this, don't use that. So just naming, and sometimes it also comes out with separating different flows for each one of these elements. Now in here, you can see that you have to select a flow as a reference flow in order to let the software know, okay, everything comes above it becomes the superstructure, and below it becomes substructure. All right, so okay, we're going to go ahead and say, okay, this is my reference flow, level 1. Okay. And then I press next. Okay, so this is the most important part when you start importing. Okay, there are a lot of people in the waiting room. Let me just get them in. Okay, so this is the most important part where you get to see different elements on the left side. Okay, and these elements, as you can see, the grid of Revit, which is also showing me the type inside of Revit is axis. And of course, are you gonna import this as an axis grid in task model? So if I'm happy with this, I say, okay, that is fine. So this is where the difference comes. If you go ahead with IFC, you may not get all of this information. Some of the information like staircases, grid, that doesn't come along with IFC for the most part. You may have certain IFC where it is there, but normally it doesn't come with that, and finishes. So finishes also doesn't come with that IFC. A lot of missing information tend to be there. So in that case, we miss out few of these elements. But when it comes to Revit, you have all of these different type inside of your Revit. So you can see that for the beam, you have got concrete, rectangular, and then you have a particular beam with the with its particular code and its name. So we know for the fact that this element is a beam. Okay, inside of our task software, what did it identify it as? So it identified it as beam. So that is fine again. And now if you go down to column, then you get to see that all of these elements with this Revit type got identified by the software as column. So are we happy with this? If it is the case, yes, it's okay. Otherwise, we can go to the drop down and say, okay, this is not actually a column, but it is something else. So I can select that from the list. Is it a stiffener? Is it a vertical projection, wall, something else? So I can choose from the element list. Okay. Similar thing goes for slab and different other elements. Now let's have a look at the material. So the type and material, that's where the difference comes in. So the guidebook, which I was just talking about, mostly focuses on these two. So you got to make sure that you use the similar names. Like if if you provide a type in BIM, let's say inside of your Revit, at least you mentioned the name BIM in full. So then the software would identify it as BIM. Otherwise, it might identify it as something else. You're gonna go to the drop down, find out what is BIM, and then a little bit of extra work. After that, you come to the material. So inside of Revit, obviously you either have brick common, or you have concrete cast in place, concrete, different other informations. But these informations, again, inside of Revit, you can go ahead with all of these different details, because that comes in within that. You have different categories, you find out different classification from there, you can generate all of these informations. But here itself, the software has got, because of the quantification, we don't necessarily go ahead with a lot of details. The material category is, for the most part, is to get a classified quantity, so we can segregate it based on the material. Okay, so then the software basically, based on the information here, let's say for instance, if you have any element which is coming within brick, then you have to say brick, otherwise the software is going to find out something else. So similarly, you go ahead and say, okay, concrete all the way down, but obviously for BIM it should be concrete. There was some problem with that. So if you see concrete, the software identified as in situ concrete. Is it an in situ concrete or precast concrete? You're going to select that, because that is our BIM element, right? And then once this material matching is done between the Revit and TAS, that is it. I mean, most of the works are done. You can just cross-check all other elements as well, just to make sure everything is fine. For wall, for instance, we have got right here, it says thickness is 400. Based on this, W40, and then right here it's 500, this is 600, and then we have the wall, and then in situ concrete all the way. What's the material? You get to see, okay, it's cast in situ concrete wall, which means structural walls. This is not really a really big project. It's just a small project, just to show you how the system works. Obviously, you can dig down much more, but what I suggest is that if you look at the guideline, which is also available there, I can share with everybody. If you have a requirement, we can reach out, of course, to iWorkstation, and you can get that from them. But that guideline would then show you how to build up a Revit model in order to get it inside of TAS and just run the calculation in one go without any hassle. So it is what it is. Now we have to figure out what is what, and then after that we can just go ahead and press next. Okay, so what's happening now is that it's importing all of this Revit information, and now it's asking me, okay, where do you want to place it? So it's basically locating the model. So I can say, okay, somewhere there or somewhere else. So we are just sticking to the place where the software wants to place it, or the exact same coordinates. So that's good. We're going to go ahead and press OK. Import completed. You are recommended to run model check. Okay, this is where everything starts. So model check is the most important part of all of this that we looked at so far. Let's just have a look at the complete model first before we go ahead with model check. So we get to see this is our display setting. Okay, we're gonna turn on that. It's just graphical imports that you get to see in the other project as well. Not really something complicated. It's just a small structure just to show you how the system works. So this inside of Revit, if you see it, it is right here. Okay, it's right here. Okay, and this particular model I just imported in the TAS software. So let's just get back to TAS. Okay, so over here you get to see that. Okay, some people are still trying to join in. Okay, so over here you can see that there is a lot of information which just came in, and then I want to figure out which one is what, and it's always recommended to find out the floors first. So you get to the floor setting, and you get to see that all of these floors are there. Okay, with their different heights. Okay, now it's time for us to dig down more and try to find out which floor is containing how many types of material. Okay, so let's just go to our current floor view, and then I go to my, let's say, mezzanine floor only. What I can see here is that there is no column. That should not be the case, because I want to have a separate quantity for this particular level mezzanine floor, or let's say, I don't know, maybe level 2, for instance, or any of this in between. Canopy, there is one level for that, and level mezzanine. So this level mezzanine must give me a quantity for column as well. Why it's not there? That's the question. The problem is that when somebody built up this beam model inside of Revit, they considered the column is going for the throughout the building. I mean, it's going all the way up, and that is the case. I mean, in reality, but then it is recommended to cut it down into different floor levels in order to get separate quantities inside of your task. So that didn't happen because of the modeling problem. So if you follow the guideline, you get to see, okay, you have to actually cut it off at that location, instead of providing that inside of your Revit properties. You provide those information where it should be for a particular column, let's say. That should not happen. That should not go all the way to the top. You have to separate it in order to get separate quantities. So that's a condition there. Similar thing is also applicable for walls. So if you are on the if you are on the same floor, you go to your, let's say, level 1, and then I'm going ahead with our beams. Sorry, not beams. Let's just go ahead with wall first. Wall. Now I get to see that there is basic wall 40, 50, and so on. I go to my bed select, try to see which one is 50 mm, 500 mm wall. Okay, so these are the ones. Now I can see this is my whole building actually, but it is showing me that for different level it's going all the way to the top. Again, this should not be the case. It should go to the go up to a particular location. Now, if you go to the details here, it just shows, okay, it's following the same thing. The top elevation is 9.87. Okay, now let's have a look at what's 9.87 here. So that is basically within right here. I mean, it's going all the way to the top, just below the level 2, of course, a little bit down from the level 2 because it's 1. So it is basically showing me that it went all the way from 002 up to the top level. Okay, which should not be the case in order to fit in the model. So this is how you get to see what is happening inside of that. Okay, so that's there. Now, if you go to okay, so these staircases, it probably got listed under any of these elements. So if I go to staircase and I get to see what are the staircases, these are the staircases now we have. And then if I just run calculation for them, okay, calculate selected entity. I'm just going to consider everything is because, if there is a beam passing by or any of these stuff, so it needs to consider that. You go to the quantity and you try to see the quantity for, let's say, all of these floors, and try to see the quantity of my straight flight. It shows me that this is the volume of concrete. Let's just see what are the things that we can see. Okay, volume of concrete is just giving me area of formwork to the open string, area of side, weight of rebar. Not giving much information about railing and other stuff because it wasn't there in the model. Okay, so similarly, if you go to column, you have got different columns. You can go ahead and try to find out which one is what, and you can make changes. What's important to notice is that you can import your 2D drawings of this particular project. So you have a set of drawing, let's say GFC or IFC drawings, and then you start importing those drawings and then refer to each floor. So let's say if you are level 1, you have your level 1 drawing, you can bring that to the axis grid and start looking for the elements which are available and if there is something missing. Okay, so let me just get to the actual stuff that we must do, which is the model checking, which is more or less just like where it is. Okay, it's just right here. Model checking is more or less like a validity checking, like if there is any problem in the model. So it shows me that there is no problem, but there is some overlap. Very important to notice this one. Is because it does not have much effect when you have a Revit model, but in some cases, Revit model do have this kind of problem. There is some overlap. So if you just double click on that, it shows me, okay, there is overlap between these two beams. Okay, what is this overlap? So you can then figure out what's happening there, why it is showing me overlap. So it is showing me, okay, this particular beam, which is this one, is cannot overlap with this one. You can see there is a overlapping. Okay. Now I don't know personally. I mean, I cannot say it's 100% true. But if Revit is calculating this particular quantity and considering this quantity to be in this beam, and again it's considering the same quantity to be in this beam, then of course there is double quantity. We have to pay attention to that. But I'm not sure. I'm not a Revit guy, so I cannot get into details how the calculations are happening. That's a separate topic. I mean, Revit expert can tell you. But if the calculation is considering the quantities 2 times, then there's a huge problem. We don't want that. Now, this kind of problems are, I wouldn't say that it's always the case, but yes, most of the case we tend to get this kind of problem. There is a little bit overlap. And that is where KBCOST is actually showing you where are the overlaps. You can argue about the class detections and other stuff, but that is happening between different elements. It's not happening between the same native elements. So here, for instance, we're looking at only beam, and it's showing me, okay, you cannot consider the same quantity or volume of concrete, let's say, for 2 different beams in the same place. So overlapping problem. You can get to the next details as well. There is also some problem happening. We can get into details and try to find out what is what. It shows me something is wrong here as well. So things like this, it is getting into real detail, and then it's giving us option of making sure that you want to, okay, there is problem with this slab as well. The problem is cannot overlap with this one once again. So which one is overlapping? We get to see that, okay, this slab is overlapping with this one. Okay, probably some of this side. We can't really see it at the moment, but it is happening. Okay, so we have to be really careful about where the overlappings are. Now, once you have all of this overlapping or whole overlap, if it is whole overlap, it's going to show you, okay, this element got overlapped with the entire one, partial overlap, things like this. And then these are the basic problems in Revit model that we normally tend to get. And then you can get into the setting right here. So setting shows you the software is following the measurement rules, which we discussed about or talked about yesterday. Indian standard 1200, IS 1200, if you talk about that, that gives us different clauses for how the trimming should happen between different elements, which should oversee which one, which should be below which one level wise. So you get to see that if it is for wall and beam, okay, if it is for column, if it is for still element, if it's for pile, that's giving me different options. So it's saying, okay, if the overlapping is this way, then and then if the overlappings are this way, then what's going to happen is that it's going to trim out this part. I'll show you here. So it's going to trim out this particular section if the overlapping is happening this way. If the overlapping is happening this way, then it's going to trim out this part. So from the some measurement in order to finalize the trimming part or delete of that particular overlapping. Similar stuff for different elements there. Now, once you are happy with this information, you can say, okay, now because there are problems in the model, I don't want to get into details and fix each one of these beams and slab. Ask the software, do it for itself. I mean, if it does. So let's just have a look at that if it does. So there is 2 options. One, trim selected entity. The second one is trim overlapping entity. Okay, so what's happening in our case is basically an overlapping entity. So we can just say, okay, trim all the overlapping entity. Okay, that should solve some of the problems, but some problems still remains there is because it could not sort that out for some reason. Then we can go ahead and say, okay, delete one of these or ignore this. So this is basically ignore it. I'm happy with this, just ignore it. This one as well, I'm happy with it, no problem. You can have a very detailed view and say ignore it. If you are happy with the quantities, I can say ignore this as well. Or otherwise, you can go ahead with this option. You can produce an error report and you can just save that in HTML format and for your reference after you ignore them. So for your future record. Okay, so let's just say we ignored all of them and then we say auto process once again. Okay, so that's now that my model checking is done. So these steps are always in my model. Do the steps. After you go say, okay, now I'm my model, everything is finalized. In case, as I said, if you would like to import 2D drawing and cross check, that is again something that you can do, and then you can say calculate. So showing me, okay, there is this partial overlapping. Do you still want to continue? If you want to continue, that's not a problem, and then I just calculate. So this is how it. My screen wasn't sharing for a long time. Okay. So I could have actually built up of architectural elements probably, or with the finishes, and that could get into details, but that would take a lot of time because we want to get to various details now. We can try it out at later stages, not a problem. Details of what we looked at so far. Okay, I would allow our participant to ask questions just in a while. So let's just look at the normal workflow of Revit to conclude with. So if you are a consultant or a design consultant using Revit, you can work out your cost plans. You can prepare your cost plans using QB cost. Just you have to import the model and 2D drawings inside of your QB cost task software, and then you can produce your cost plan. And then after that, you can then start doing the tendering drawings. And then with the tendering drawings, you prepare your BOQ. And then you can go ahead with construction drawings and quantity check. So these drawings are always there from the model itself. And then you can proceed with QB cost for different quantities. So cost plan, tendering, construction stages, 3 different stages. You are preparing quantities using the QB cost side by side. What's important to notice is the reductions, the overlapping, the rules of measurement. So these are the main differences between the quantities of Revit and tasks, QB cost tasks. Similarly, if you this is basically when you have all of these information in place, but then if you have Revit model, if you don't have those 2D drawings, then how you deal with it? You have the Revit models and 2D drawings, and here you have the Revit model in between every cost estimation, is because you tend to follow the same model in every stages. So it's under development. At one stage it's maybe already 100 and going to the 200 and to 300 and 350 and 400 500, but at each of these stages you have QB cost side by side. So you are importing the latest model inside of your software, and you are running the calculation. Again, if you are following the guidelines while modeling the BIM model, it's just little exercise of adjusting things here and there inside of Revit. And if you follow that modeling guidelines, it's not going to have any error after importing that. So that's the concluding statement. Okay, now here we are looking at again some issues related to the software, typical issues. So sometimes we can look into details of various things, like you have to have separate. You can see that this one is showing that it's horizontal grab bar for wash basin. Now you may want to have a quantity for this particular grab bar, but then it does not have any quantity inside of tasks, because it's considering this that the whole element is a wall. So you might want to go ahead with only wall. So instead of core central line, that's the location, by the way, you can have that particular basic wall Okay, and the software is going to tell you, the task is going to identify this one as cubic cost is going to identify as wall. So it's going to give you quantities for wall. So you are happy with wall information for now. Similarly, in here, you can then see that there is this problem of overlapping. You have to separate it. You have to say floor wise. If you go ahead with a rectangular column without finishes, this is the size, that's the type of it. But then it's getting throughout the building. We don't want that. Similarly, basic wall, again, when you select this basic wall, it's saying, okay, it's going also a little bit inside of there and stuff like that is creating an L shape, but that should not be the case. Separate element it should be. So always pay attention to details of which element should be what. So that's basically the modeling principle. In here, we can see that this is a casement aluminum window. That's fine, no problem. The software, the cubic cost task software is going to identify as the same element, the beam and the actual element, which is basic wall, is getting a different names, and which is why there is a problem with that. Now you can see that this is the basic wall, which is all good, but if you call this particular frame as something else, then there is a problem. It's just making it differently. Okay. Similarly, you should not have this with another name, and then you can have, for this particular part, that you may want to call it as an opening or window or something else. That should not be the case. You have to call it as a complete wall going throughout, and then you can say, okay, there is another window. If you say there is no wall and there is a window, then you may want to end up with less quantity of wall. So little bit of principle, but it works well when you follow those principles inside of your Revit modeling. Okay, more or less similar thing here. You can see if you go for the entire all the way to the top, then it tends to show you inside of your Revit model that is actually going throughout the building, these columns, and then you tend to get one quantity on the ground floor, and then you find it hard to actually separate them out. So in that case, you don't do that. And sometimes you have then different, wall finishes, for instance, you have different errors because inside of Revit, you have a lot of overlapping for the finishes, which does not make any problem in Revit. But when you importing cubic cost task software, it's going to tell you, okay, there's overlapping in that. So you have to pay attention to that as well. Okay, so this is again showing you that you have to get to the level of your floor level. So starting from here to here, so that is a correct way of working inside of Revit. You should not go throughout the building. You should go part by part. So things like this. Okay, with that being said, we can proceed to the next topic. If you have any questions, you can always put them inside of your inside the chat box. I will address them as I move along. IFC I got a question from Mr. Rajesh. He's asking, IFC has issues a lot. So there is still data loss, right? Okay, so of course, when you talk about IFC, we spoke about it before as well. We do have data loss, but if you have a complete Revit model, you tend to have less chances of getting most of the part. You don't get any data loss. So let's just show you. I'll just quickly show you inside of this project itself an IFC model to deal with. Okay, I will just create a new project. That will be good. IFC project. Okay, so in IFC, I will show you the difference in IFC. It's basically less information. That's the major difference. And then you tend to have the axis grid that you are setting up, basically. But in Revit, obviously, it's carrying out the grids. So with the grids, you have the axis grid. Okay, so let's just go ahead with the beam modeling part, and then we say IFC import. So same principle, except for the setup. So you have this particular IFC files, Canberra Tower. I'm gonna just again import this. I'm just using, by the way, just the structural model, not really getting into details of architectural thing, because architectural elements are all over the place. So you may want to get into different stuff and make sure that everything is importing properly. Okay, so footpath finish floor level, that's my reference flow. That is basically the superstructure and substructure difference. And then I'm going to go ahead and say, okay, next. So again, matching up the material. Sometimes you may lose information in regards to the finishes element. But here, for instance, you get to see for beam, I have this particular rectangular beam with this size. Similarly, showing us this element, this material with the beam. Okay, so let's just go ahead and say next. So it's importing that IFC model. Now, you might have noticed already, we did not have the axis grid, which is coming along with IFC model. So grid is coming with Revit model, which is again the difference here. Right. So now that we have our IFC model, which is getting imported, of course, it has got different flows, so it might take a little bit of time. Okay, Mr. Adnan is here. Okay. All right, so I'm going to go ahead and press OK. This is it. My model is more or less just imported. You get to see this is my model. It's an IFC model. Okay. You can see the staircase came along. That's a good news. You have different informations here, but as I said, it's more or less just the structural model that I'm dealing with at the moment. And then you can also have architectural model. You can have the finishes and stuff. Modeling, check up the model check, and verification, and then quantities. Okay, hopefully that answers your question. Another question from Mr. Raj. Anything more with Revit LODs? Do I need to have the Revit model part with LOD 400? What will be the difference? Will there be a difference in quantity estimation? Well, quantity estimation, estimators as the QS or estimator, we tend to use different drawings. It's not, and if I just simply answer your question in this way, if you have a drawing at a very early stage of project, you have only the conceptual, maybe as schematic design. It's just the concept or a very much basic level plan, and then from there you have to determine in order to get to your order of cost estimate. That's a particular set of documents that you need to prepare. And then after that, you get to the cost plan 1, cost plan 2. So throughout the project life cycle, you have different stages. And along with that, you have the BIM model with different level of details or information. You have the LOD 100 and so starting from, again, there 200 and 400, as you mentioned, LOD 400 and LOD 200. So you can basically utilize any of this model at any stage of your project. Now, if you're not QS, you would just necessarily think that, okay, if I have a complete model, then I may perform the calculation, but that's not the case. At every stage, you have to have calculation side by side of the quantities. Now, if you're doing the calculation side by side, so along with your model development with different LODs, you are updating the model and getting the quantities done. So that is where QB cost comes in place, because you have to have a constant track of your quantities. It's not just one LOD and then you get to the final model and do another calculation. Now, throughout the project, you are doing different calculations. So that is where the software works out well with either LOD 200 or 400 during construction. Okay, I would probably answer more or less more questions at the end, if that is fine. And I would take it more into the details, but obviously due to the tide of time, we won't be able to cover as much as we are looking forward to if we just go ahead with this. But yeah, I'm taking all your questions. It will be great if I can answer them at the end, or I just put it in a little bit of wording formats, if that's fine with you. So let's just proceed with the next topic. I got a question also from Mr. Bipul Kumar Rice. Please don't mind, I'm going to take it at the end. I believe that would be okay for everyone. Okay, let's just get into the rebar quantity takeoff. There was a question yesterday as well. So how we actually deal with rebar? Okay. All right, so this is TRB software. Now, if you remember correctly, we spoke about TRB in our last session as well. So TRB is basically a takeoff for rebar. Again, this is coming within the suite of softwares in QBCost. So QBCost TRB, you have again different tools under different tabs. I don't want to go into details, more or less you already know what are this stuff. And then you have the attribute editor. It's basically the properties of each one of the element that we have in the model. I just picked up only a basement floor and a little mezzanine here, just to show you how it works. Not really a detailed model because we cannot go into so much of detail because of time. We get to see that all of the structural elements are more or less modeled inside of this particular model. You can do this modeling either in task software. You can build up this model in TRB itself, which is the current software that we're looking in, or you can build up this model in TME, which is for MEP. Now, if you build up the model in MEP and then you bring the model here, because this is native file, so it works out well between the software. Okay. So all I did is I just went to my BIM model and I just imported the model. Of course, okay. Now that I have my model, I'm going to go ahead with a little bit of rebar calculation. So I will just go to my current flow, which is my ground floor. Okay, let's say as an example. Actually, let's just work on, okay, ground floor is fine. Now in here, you get to see that I have different columns, okay? And then I have mezzanine floor and I probably, okay, that's not a problem. But these are the drawings that I have in the 2D drawings that I imported. And the properties of each one of this column can be seen here. Similarly, you can see the rebar information in this particular window. Okay, and then you have the modeling part. You get to the single element where you basically do really going into the full building, but you just focus on one element at a time for determining the rebar quantity. And then you can go ahead with BOQ and report. So we'll look into details of these two very quickly in a while. To start with, you can go ahead with, let's say, column 1. You have two options available with you. Again, identification pretty much same as task, which we looked at yesterday. Okay, if you go ahead with identify schedule, it's basically expecting us to have a complete schedule of rebar information. Let's say a column with its size and its main bar and its rings and stirrups and all of those different information and links. So if you have those kind of details in a schedule, then you can go ahead with identify schedule. It's going to basically pull in information from there, and then it will feed inside of these columns here. But then if you have identify column details, what is column details? I'm not going into details because that might take a little time. Column schedules, I'm going to just show you a schedule here. So you may have certain setup just like this one. Okay, restore CAD entity. I'll just show you how it works. All right, so all these rebar informations in a tabulated format under identify column details. So I say original CAD layer, show me the entire drawing. It shows me, okay, this is my column schedule. So sometimes in our project, we tend to have details like this. Sometimes we have in our table. So both ways you can still identify those information. If you go ahead with identify column details, you have pick sideline, which basically means you're going to pick up the sideline of column, pick label these labels, pick rebar line, you pick up all of this rebar auto identify. That will feed in all this rebar information inside of our model. We're not performing this step is because I already did that before. So it just works same as task software. Okay. Now that I have, let's say, identify all of this Rebar information, it should, even if there are maybe 200 numbers or hundreds of columns in your project, the software should apply all of this Rebar information to different columns. If I go to my column 1 and I get into details of it, it shows me that there isn't any Rebar information fed in yet. However, in column 2, I have some Rebar information here. Okay, so this is basically my edit section. If after identification, if I would like to get into details and try to figure out, okay, I actually need to make changes, I'm not happy with those stuff that I could see there, then you can go ahead in details and say, okay, 4 numbers of T20, you have the input for 4 T20, or you can go ahead with 20 plus 22, and it shows you different details here. The plus basically means that the different Rebar information is connected by plus. So you can probably have a mix of 22 and 20. Similarly, different input formats are there. Now, if I just go ahead with the simple format 40, 20, I have this 20 main bar here in all these 4 corners of my column. Okay, so that's getting in detail. Now, if I go ahead with the links, I can then go into details of all of this information. So I can say, okay, 40 numbers of T8, or I provide a spacing. So let's just say I'm providing a spacing. So I'm going to say, okay, it's not by section, but it's actually T8 at 150. Now there is another setup as well, which says, is it densified or non-densified? Watch what happens when I say densified. This one is the one. So it separates by this slash, and it says densified spacing and non-densified spacing. Of course, I would expect everyone know what's the densified and non-densified zones in a column links. So it gets into details of that. But what I'm trying to show you is that you get to see in real time the information here, if you are not satisfied with the identified information. If you are happy with that, you can just proceed with calculation, done, khalas, that is it. But then if you would like to go ahead with a little bit of extra information, try to find out which one is what, you'd be actually able to draw a link, okay, an extra link you probably want to put in. So I say, let's say I just increase my number of rebars, and I'm saying, okay, there are 220 here as well. So I'm going to go ahead and say, okay, I would like to draw a link. So it's asking me, what's your link spacing or rebar information? I'm saying, okay, this is the one. And then I would like to draw a link by line method. So pick up these 2 points, and that is it. Okay, that's my link there. So similarly, you can draw all around and stuff. You can draw, delete, whatever you want to do. So that's there. And just, you can side by side, you can check with your original information and make sure that it's actually getting into the right shape. So I've got C2, which is done again, identified from the schedule quite well. I have the C4, a really complex set of rebar there in C4, and C5 is there. And then you have C6, which is a round column with this different information. And it shows you right here the main bars and the links. So you can actually get in details, and you can change there as well. You can say, oh no, it's not 16, it should be less than that. All right, so that's enough information for now. Let's just get into details of our rebar calculation of column. So now column, more or less, we have columns on ground floor. If I get to my mezzanine floor, I should have my beams as well. So let's just have a quick look at one more element, which is okay, I have shear wall. By the way, in shear wall, horizontal, vertical, main bar, binder, hoops, all of these different information you can input, and it shows 2 in bracket, which means it's going to apply in both phases. If we're going to go ahead with one phase only, say one phase, and different other input formats are, you can go into various details. Shows you different sets of rebar information, how you want to place them in. So you can choose any of these. I'm not going in details with wall. Let's just go to beam. Okay, beam. All right, so in beam, you have, again, similar information here and here. But then in beam, you have different other options, which are, again, I would say that for beam, you have to have, if I would just turn it into only 3D view. Okay, that's already in my 3D view. Okay, these are my beams. So beam schedule, that is one, just a normal schedule. I'm not going in details with that, but normally it gives you a really detailed information about beam, and that can go on, and you can figure out different complex rebars getting everywhere. So you can go into details of which floor that you want to create. So you can say new beam rectangular, and then you're gonna say, okay, I have a span, I have another span, and for each one of this span, you can have a beam marking, a beam type, and then what's your left rebar information. So I'm just gonna say, let's say, 2T16 maybe. Okay. So as soon as I place that, it's actually recording there. Now I have to have a beam here. This beam should be either B1 or B2. So any B1 that is in my project will then get this left rebar top bar. Now, what's left top, you will be able to see in this particular drawing. It really gives us all the details of what's slabbing, what's the length of support bar, what's the extension, what's the center line, everything. So based on that, you provide all of these informations, and then the software is going to place all of them in position. And you can just create one particular beam schedule, and that is it. The software will place all of this rebar information in there. If you don't want to create that, you still have identification options. So you may want to have a schedule already ready in Excel, and you can just bring that up as well. That's there. Similarly, you have auto identification options, which are again applied to other beam. There is one specific function which is identify beam schedule. Okay, identify. Yeah, this is Excel. That one was this. Now, site labeling is basically you are going to pick up the labels of it. So a lot of informations along the way. You have margin element entity, batch identify support. Support is quite important to, if you pick up a support, it shows you what are the rebars being fitted in. You want to make any changes, you can change them. Stuff like that. Okay. Let's quickly have a look at our slab now. So okay, so these are my slab at the moment on my mezzanine floor. Okay, I already applied some of the rebar information. Hopefully, I'll just able to delete some of them. So I just go to batch select. Let's just delete some slab main bar, so that we can create some main bars. Okay, so all you need to do is you can go to the slab main bar. All right, and then after that you have all of these different main bars here. Now these main bars, you basically created them saying that, okay, these are the main bars. Okay, so all the work that you are doing is just setting up a set of information here based on your drawing. If I just turn on my drawing just to show you what I mean by that, it should show me the rebar information. Okay, so it says 250 mm thick flat slab having this rebar information both ways, top 150 center to center, again 150 center to center, T2 for both ways bottom. Okay, so good information there. Similarly here also we can see that it should be T10 and T10, again 150 mm. What I'm going to do, I'm going to create a lot of this rebar and calling them top, bottom, and so on and so forth. And then I can say arrange main bar for my project. And then I'm saying, okay, I just want to go ahead with continuous, which means pick up all the slabs that I have in the model. So if I can pick up this slab, the other slabs as well. And then all I need to do is I just go to my arrange main bar. All right, it works good with the 2D, so that's fine. Arrange main bar continuous, I pick up that, and then I can say, okay, arrange it both in X and Y direction. Okay, perfect. Now I can just right click, and then now it's asking me, okay, X, Y direction. So in bottom bar X direction, what's your diameter of rebar? I'm saying, okay, T10. What's the Y direction? It's T10 as well. Top bar T10 as well. T10 top. Again, in Y direction, it should be T10 as well for this particular slab. As we can say, it's T10. And then it's asking me, okay, do you want to place it in this particular along the axis grid, which is this way, or you want to place it something else? So if I just skip this part, I'll be actually able to say I can pick up, let's say, parallel to something or 2 point. I pick up 2 points and it will arrange in that particular direction. But direction swap and all of those stuff are another topic. Let's just proceed with OK. Now what happens is that it creates the top rebar, which you can see in yellow mark. You can see also in the blue color, again, another rebar set. So that is my bottom bar. Now let's just go ahead and press calculate. Calculate all of this, let's say. Okay, so if you run the calculation, you get to see the rebar information in details. Now, if I just pick up all of these rebars, let's just say, okay, I want to see all of them. I can see all of them. I go to Rebar 3D, and that's my rebar there. Okay. Now, if I just say I want to get to see only one, so I can actually get to see one only. I just go ahead and say, okay, I just want to see this guy, and then Rebar 3D. Okay. So that's my bottom rebar. And this bending, the hook, and all of this information, anchorage length, lapping, or any connection setting, coupler, this stuff comes from the rules of measurement that you have chosen, or the rules that you are applying. So we'll look into details of that in a while. Now that we have this rebar information, we can go ahead with rebar layout. Okay. And this is again allowing me to just draw the rebar information here and edit them here if I'm not happy with these informations. So that is again giving me another access to the rebar information. I can choose them and select them and say which one is what, stuff like that. But if you go ahead with Rebar 3D and edit rebar, what happens is that you get to see, let's just pick this rebar, let's say. Okay, so it shows me that this rebar is this one. And with details here. How did the calculation took place? It's 12 times diameter is that little bit of bending, and then there is this, and then again says there is a 12 times diameter on each side. Okay, and then it's giving me explanation as well. Net length is this much, set anchorage is this much, set anchorage is again another option here. And if you go into details of various rebar, it shows me various details side by side, all of them. Now that's not just specific to this. It gives me details of everything, and then I can get to see the calculation formula over here, and the description of formula, what's the cutting length, what's the total quantity, what's the bar information, is it Y direction or X direction, everything in detail. All right, that's about the rebar information for our slab. Okay, I'm not going in into details of the rebar of other elements like foundation and other stuff, but you can go on and find out more. So let's just get to one particular function, and that's, I believe, the most important part that we always want to look at. So inside of our flow setting, we have all of this different information. The anchorage length, different setup for each grade or type of rebar with their diameters. Okay. Similarly, you have a setup for lap length. Now these values, 32 times D, 26 times D, from where this came. So we want to get into details on that. You have again separate category for seismic zone, or what is the seismic grade in your place. So you can then say, okay, it's 4 number, 3 number, it's non-seismic and stuff. All right. So if I get into my anchorage and lap length, okay, this is where everything is coming from. So you get to see that this particular formula for determining the anchorage length has been applied from British Standard 8110. Okay, and then it's getting into different coefficients, beta. Then in here you get to see different information like LB, which is basic anchorage length and stuff like this. So basically, every calculation that we saw the result out here is coming in from here. Again, you are getting into details of, is this particular element is in tension zone or it's in compression zone. So you can go ahead with tension zone length, compression zone length, different setups are there based on the grade of rebar or the type of rebar, and then based on the diameter you have set up. Okay. So this much detail you get to see, and then you can say, okay, I want to round up to something else. So you can have another. This is just a setup of your precisions. All right. So that's all about it. The calculation rules. You get to see a lot of rules being applied between how the connections are happening between different elements. If you just go to, let's say, wall and go into details of that, it shows you a lot of information here. If there is a let's say I just pick up one of these options. What if there is a connection between the end of wall? So inside of your end of wall, how do you end it? So you end it in this way, you end it in this way, in that way. If you go into details here, you get to see different options. And these are again from the rules, standard measurement rules. So you have to then pick up that and you can then change this value. Okay. Similarly, what about the outer bar? Is there any additional outer bar? So based on your drawing, you can edit all of these different informations. Top of wall, how it should end, if there is an opening there, and things like bottom of wall, how it should end with foundation, how it should end with foundation. Is it this way or that way or this way? So stuff like this. And then you can go into details of the openings inside of your steel fabric, which is the ready-made mesh, the BRC mesh and stuff like that. Beam, similar setup. Slab, similar setup. Staggered distance, how you're maintaining that. If there is an opening in the slab, how you're arranging the corner trimming bars and stuff like that. Similarly, foundation, you have different setup here. Connections between foundation, and then if you have some pit, how are you actually dealing with some pit? Okay, these are basically calculation rules. So anytime you are not satisfied with this information, you can come back here and you can say, okay, I want to make changes. So you go down and you say, okay, I want to go ahead with 25%, 5%. I'm just showing this one. So you can get into every one of these green color information and you can change them based on your requirement, okay, of your calculation. Okay, so this gets into detail and detail. Masonry structure, certainly others. There are a few other stuff like lintel and carbs and stuff like that. Okay. Specific weight of rebar, hard grown bar, common rebar, fabric. Different setups are there. Standard information. If you want to change the weight of them, you can then change it from here. Links setting. Again, you can create new links. You can get into details of formula. And then it shows me, okay, all of these different formulas are there. 4 legs, for 8 legs, for 7 legs, and all of this. If you want to make changes in the formula, you'll be able to make changes in the formula. And then based on this formula, the software is actually creating that. If you go to custom link, you can actually create new links and stuff. Okay, with that, we will just conclude with this little information. We have hooks and bends. That's happening here as well. Then we have lapping setting. Again, inside of your project, you may have different types of connection. It's not just lapping. Let's say in your project, you have couplers. So taper thread coupler, straight thread coupler, you can get into those connection details. If it's lapping, it's lapping. Or if it's something else, you can go ahead with that. Okay, tension compression setting. So you'll be able to actually select which particular element at what location. In anchorage location, is it a tension zone or a compression zone? In the lap location, is it a tensile zone or it's a compression zone? So you get to select 4 different elements from the list. Various elements are there. So this, based on this tension compression, the software is going to calculate what we saw as anchorage and the lap length. And then finally, you have the wastage. So British standard doesn't allow us to do the wastage, but if you want to go ahead with wastage, you can say, okay, I want to put it there. So both options are available with you basically. Now, what's important to notice is that once you do your calculation for rebar, you tend to go ahead and say, okay, I want to see my result. So you can basically look into every details of your entire model by going into your Rebar 3D, let's say. Okay, so everything turned into 3D with different rebar information. If you try to zoom that in, you'll be able to see a lot of rebars just coming outside with their location of their trimming bar and then their connections. a lot of rebar. So it's always recommended to pick up just one set of rebar and just get to check that, and then you can get into details of others. Here, for instance, you get to see that there is actually slab connection happening with the column, which is why the rebars are getting a particular bend. If you are not happy with that, as I mentioned, get to the calculation and you can make those changes. So beam rebar, densified, non-densified, stirrups, stuff like this. Okay, so much information for this side. Let's just have a look at the quantities. What kind of quantity that we obtain. Okay, so for beam, let's say we are getting 8 milli, 10 milli, 16 millimeter, 20 millimeter, and then that's the total of summary, and then each one of them has got a summary level calculation as well. What beam is this? Everything in detail. Similarly, if you look at column, we have got a lot of, again, rebar calculation here. So everything is getting in place, and then you can export it into Excel setup, whatever you want to see, any condition that you want to put in, and filter options. All right, so with that being said, let's just proceed with the last part, which is single element and report. So if you get into the single element, what happens is that you have, let's say, you would like to build up staircase. So you can say, okay, I want to go ahead and say, add a staircase. You can add a drawing of your staircase that shows you the sectional view with all the rebar details, the distribution bar and the the vertical parts. So you can import that particular drawing. And then right after that, you can go ahead with creating a new. So you can say, okay, add an element. That's my stair there. You can go into details and start drawing those rebars. It's basically pick up the line and it's going to create the model. There is this parametric input, which is getting into details of a lot of staircase rebars. Again, as I mentioned in multiple times, you will be able to select the grain color information and you can say, okay, I want to edit that. So you go into details and say, okay, this is not T16, it should be something else. So you can select and make changes there. In specific, if we go to the shared foundation, strip foundation, different foundation rebar information are there. These are basically preloaded elements with their rebar information already set up. All you need to do is just say what type of rebar is this. So yeah, single element really works out well, and then you can apply it to different floors. You can say, okay, it's going throughout the floor or whatever it is. And similarly, you can go into details of, let's say, different pile types, ring beam lintels, okay, and common stairs, and that's just stairs, and then you have pile caps, and then 6 pile cap. So all of this with the 6 piles, you have that cap, hook, stiffener, a lot of preloaded elements basically, wherever it is required. And then there is this corbels, column corbel. How the rebar arrangement is happening in column corbel in case if it is built up within the column, if it's not something that is ready-made or precast. Okay, so these informations that you get inside of the software, and you can start using them based on your requirement. And what's important to notice is that all of this information gets into one place. Unless you want to model it by yourself, you can just place this information, and this is you can just copy it to different floors and start doing the calculation for single element. Otherwise, you can import, as I mentioned, import a drawing, or after importing the drawing, you start identifying those rebar information. And identification is as simple as just clicking on one rebar, and it's going to tell you, okay, what is this? Is this a horizontal bar or vertical bar? So you say, okay, horizontal main bar. So distribution bar, main bar, it's going to identify and place them according to your spec. And then you can proceed with calculation. It's as simple as that. So you get all the single element calculation done by one go, by importing the drawing or by utilizing the parametric input. Okay. The last part of BOQ is basically the same thing that we looked at in our task software. It was basically link with TBQ and start working out and the same information. You send back and forth information, check in, check out, and stuff like that. All right, so with that being said, let's just have a look at our reports. I believe the summary report would be the one that we actually want to look at. Now in here, you can see that you can produce reports based on the rebar shape, which is going to give you a really detailed view of bar bending schedule with their cutting length and bends and stuff. And then you can also get into details of this kind of summary, where it just gives you the summary of rebar. A lot of reports are there basically. You can get into details and try to find out which one is required in your case, and you can edit them, by the way. I don't have a lot of rebar information because I did not run calculation for everything. However, if you did, then you get to see all of this information in a really beautiful format. Okay. The quantity, one thing that I didn't mention is this one. So if you would just like to see the rebar of this particular column, let's say, you get to see the cutting length and stuff, and then you get to produce directly a report for this column. So in one go, you just select a particular element and you have all the rebar information with its shape, with its calculation formula, description, cutting length, and everything in detail. And then you can say, okay, export it into Excel. It is just right here, Excel. Okay. So if you do so, you get all of this information in one go. Similarly, for different other elements, you will be able to do that. If you go to rebar schedule, that is giving you a little bit extra information of total weight, remarks and stuff, just the one that we saw in our project. And then you can have the project name, so that's gonna tell you different informations here, like the name and who is actually building up and stuff. So if you had somebody who is prepared by, so you could put that information while initiating the project. Okay, so I believe that is the rebar information. Let's just have a quick look at BIMQS Cloud, the last topic for today's workshop. Okay, so BIMQS Cloud. We know about a lot of cloud platform. Obviously, more or less, we are from BIM background. A lot of information that we have in the market about cloud storage and stuff. But BIMQS Cloud, what's unique about this? There is nothing that much special if you compare with the other platforms like 360, BIM 360, and other platforms. You still have the permission settings here, which is also applicable in any other platform, and you have spaces like project space, employee space, shared space, and outside collaboration. Okay, I don't think I have to get into details of each one of them. Project space for yourself to store the project. Employee space is very much personal to you, unless you provide, you can put in security there. Private space, project space gets into details if you provide permission, so different people get to see. And shared space is basically for your entire team. There is one shared space where all the projects can be seen in case if they're shared there. And then outside collaboration only happens when the admin of BIMQS licenses would then give permission to collaborate with outside team, which could be just a stakeholder outside. And then that person will only get access to that model. You won't be able to edit that. You won't be able to do any other stuff. So only he will be able to see the model and comment on that. Okay, let's just quickly have a look at our cloud platform. Quite a simple topic. You get to see that for every model, you'll be actually able to upload it just right here. Okay, let's just go here and I'm saying, okay, what's my password? Let's say. All right, so all you need to do is you just input your cloud information, and that is it. You are logged in. Okay, now if I go to my project space, I believe I actually uploaded something there, so I'll be able to show you without getting into again back here. So I have project space, like nothing is here, but this is the employee space, which is my private space. So I've got a few projects here that I'm working on currently. So we can go to new. You can customize them based on different folders, like tender file has got these many folders. BIMQS file, project drawing, tender documents, inquiry materials, tender submission, contract files could be in another set. You can have on-site pictures, certified revisions, construction log, construction materials. Okay, employee space. That's my. Let's just pick up any of the project, and let's just have a look at the project, how it works with our cloud platform. So if I share this model with somebody outside of the KubeCost license holder, he will also be able to preview the model just the way that I'm showing you right now. Okay, so this is my model here that we saw yesterday as well. So what I'm trying to show you is that you can have a really good visual of the model, and then you have different tools available here. So you can, let's say you want to show the remaining stuff, and then you turn the other stuff. You can directly hide and show, or you can blur out, or you can have those what's it called, transparent views. Similarly in here you can see that, okay, I can turn on and off and stuff like that. So view options, basically zone wise, floor wise. Again, each element wise you get to see different information. Again, if you selected one floor, it will show you different columns. So I'm just gonna show it back. I'm not really wanted something to go down. Okay, so this is how you basically show and hide stuff from here. If you select any element, let's say on my ground floor, I just selected this particular wall, and then I get to my expression here. It shows me this is MS wall 200, and then it has got a quantity of 3.382 cubic meter, and then the calculation happened this way. So it was multiplied with this, there was deduction, blah, blah, blah. So all of this information got in place. If you go more into details, you have the area, different other information. Based on the element that you choose, you get to see the expression or the quantities in details. Of course, you can't edit anything here, but you get into details of this calculated quantities, right? Inside of here, inside of here, you have the common attributes, which is showing me, okay, MS wall 200, it's a brick, it's an interior wall, it's this, it's that, everything is in detail. And then if you go to the calculation attribute, it's again show you if there was any calculation attribute set up, construction attributes like claim was there, any payment was there, actual start date, end date, basically a little bit of information about schedules. And then you have subcontract flow zone and stuff like that. So these informations that you get inside of your properties. Now there are tools like this one. Let's just say for this extended slab, I'm just gonna measure a distance. Measure a distance from here to here. Okay, that's 3137, it's all good. But for some reason, I know that this should not be 3137, it should be less than that. So what do I do? Actually, there are different other functions that they're not going in detail. I can go here and I can say, okay, just mark this first. Okay, I did not mark it properly. Right, and then I'm saying, okay, I would like to tell somebody that there is a problem here. So I just say, okay, then I can put a comment there. So you can write a comment there. You can say, okay, oh, so the length looks incorrect, so just make changes. I press OK. So what's happening basically is that this markup or the comment is getting stored inside of the model. So the person on the other side who is also viewing the model will be able to see, okay, this person has created a comment and this is the comment. So if I click on the comment, it gets me back to the place and shows me, okay, this is the place where the problem is. So really in detail, so you can create different comments, you can just reply on the comment and stuff like that. Okay, one last thing, you have the scope box or section box, which basically, of course, you more or less know about it. You can cut it at different sections and you get to see what's happening inside of it. And, you can start placing different, putting different comments on each one of these elements. You can do it in Y direction as well. So the Z direction along the height, X, Y is there all the time. I believe that is it from my side, and let's just finish our workshop with few last thing. So as we saw that the total platform what we looked at in our workshop was based on intelligent functions. Visualization was quite good, and then we had interconnected platform between the pricing or tendering software with the Takeoff softwares. But obviously, unfortunately, we couldn't able to look at MEP or the infrastructure software, but in future we'll be able to do that. So we may want to have another workshop in future where we will discuss about the MEP and infrastructure. All right, so that's about the BIMQS suite of software that we looked at. But other than that, the workshop was intended to get into details of how quantity surveying is actually getting involved in the workflow of building information modeling. So that was the main intention of it. But obviously, I was looking for different tools, and this is one of the tools that we use at the moment. So I found this quite useful. So thought of putting it up front so that we get to go ahead with a lot of information out of it, and then we can start working our way out and try to figure out which one is good, which one is bad, what I should actually get involved in. And for me, to be honest, I tend to look for the tools which are ahead of time, which should show me, okay, what's going to happen tomorrow. It's actually already thought of. It's not always a competition between Autodesk and the other software, but rather it's about the field that you are working on. So let's say if you are into quantity surveying, this is just intended for quantity surveying. There isn't any much about modeling. You can argue along this point that, okay, if you want to have really nice visuals and stuff, and you want to do the rendering and things, no, it's not going to happen in this software. This is just for quantity surveying. So things like this is specific to the work that you want to do. And the software is, in terms of commercials, it's much much cheaper than many of the Takeoff softwares in the market. But I'm not talking about sales and stuff, but I'm just giving you an idea. So if I get to see different questions along those lines. So obviously, Mr. Ahmed can answer all of these questions from his side. So you can always come back to us in our workstation and get more information about the software or the tools if you liked it. Also, if you have any suggestion or recommendation, you are most welcome to put that in. As I mentioned before, if you spend a little bit of time putting in different questions, and with that, you can also actually put in your name and your email ID. That's really important because we're going to give you access to the online platform. So start putting in your name in the chat box as well as your email ID. Just type in your name and email ID. Don't forget to put email ID together. So name, email ID, both together. All right, so looks like, okay, many people are just started typing it, okay. Just put in your name and email ID so we can send you information regarding the online platform that we are going to give away as a free access for the lifetime, and you will have your individual information there. Name and email ID is not just the name. I get to see a lot of names. Please type the email ID as well. That's really important. From iWorkstation, I would like to ask Shraddha to record all of this information and what we can see here. If it's not getting recorded, hopefully we'll get the chat information. But if it's not getting recorded, please feel free to just copy this information on the other side. So we have this information ready. With that being said, yeah, of course, I would just like to take some questions probably. But yeah, as I said, QB cost is just for quantity surveying. You can have your Revit model side by side. You can try out this software. But yesterday we had a question of trial and things, but these are there, but it comes along with the program. So you may want to contact iWorkstation for future references, and they will be able to tell you how you can obtain license. Even if you want to get it for free or try it out, there are ways around it, but you have to contact back Mr. Adnan to find out how to get into the tools. All right, so with that being said, let's just conclude our session with the final remarks, with the questions and answers, and let's have a discussion. I believe I don't see Mr. Adnan in the room. Probably he is. Okay, yeah, he is there, but unfortunately, I think his microphone is not working yet because of the bad internet connection. Okay, so we got a lot of responses. What I will do, I'll basically ask Mr. Adnan to send all of these informations that we covered to individuals' email, and you will get